Hey, so we are back, and we're going to jump to, like I said, one of the other areas we're looking at is AI, right? Now it's come to dominate everything, right? In business and industry. Yeah, it's a huge part of the world, and so I thought I'd look at one of the papers that kind of set this up. So, sort of going back a little bit into the history of when there were innovations in AI, and this was the sleeper hit that gave us the advanced human-like neural networks that led to the huge advances in really sort of the generative stuff, novel behaviors, and it also led to the massive shrinking of the size of the of systems, which allowed the production of androids, which have been really because the robotics pushed along as well, so that all got pushed along, right? So so let's and again it was a sleeper hit because it came out of one guy who was working in a hospital. He was working in Bethlehem Royal Hospital in the UK, which is a psychiatric ward, right? So and a single author paper changed everything, changed the whole world, right? So not widely seen at the time, but then picked up later by other authors. So definitely worth reviewing, right? So the title is, so it was in the Journal of Integrative Neuroscience as well. So that was the other thing. So he wasn't publishing in AI journals, right? So, which is a cool thing. So, human mind inspired artificial intelligence neural networks. Just straight up, I love the title. It's just, bam, this is what we're doing. Okay, he took that next step. And so they're saying, oh, look, neurons, etc. He went for it and was just like, we're going to build the whole architecture off the human mind, right? All the different layers and everything. He scoped it all out because he was a psychiatrist by training. Yeah. So he understood, the sort of mental models of structures of the layers that we, kind of assumed that the psychiatrists and counselors and stuff worked with for how the mind works. So he said, let's do that, right? Let's stop fucking around and just go for it, okay? And that led to incredibly complex and advanced AIs, and also it led to the huge shrinking, right? So the massive server shrinking. So then AIs could be in every business, right? You didn't need to have, 20 miles of servers under Alaska, yeah, to have a big deep mine style thing, right? It changed the world. So single author, psychiatrist. I think he was a Greek guy, Theokis, based out of Bethlehem Royal Hospital. But also interestingly, so a thing that is a little bit disturbing is, of course, he wouldn't be studying normal minds, would he? Yeah, not that any mind is really normal, but he would be studying, people in a psychiatric ward to build his models. So bear in mind, this paper underlined all the AI, the future advances in AI. Not quite all, but a lot, right? Maybe some of the swarm intelligence guys, which we'll get to another time, is another thing, right? So let's just jump in, right? It is becoming increasingly evident that artificial intelligence, AI, development draws from inspiration from the architecture and functions of the human mind. This manuscript examines the alignment between key brain regions, such as the brainstem, sensory cortices, basal ganglia, thalamus, limbic system, prefrontal cortex, and AI paradigms. Yeah, so first of all, he's talking about just the actual physical structures, because you got to remember as well, like say visual cortex, right? That's a visual AI, right? Yeah, so all those sort of visual interpolation models visual cortex, right? So he has to do the physical stuff first. And the area of paradigm including generic AI, machine learning, deep learning, and artificial general intelligence, right? So he also comes up with the proposal. So, it's a big out there now whether we got it. Yeah, people are not really like, kind of, yeah. Like, again, I was always like, how are you going to know? Right? You pull a random dude off the street, no university degree, like, we had AIs that would probably outperform him in pretty much every way a long time ago, right? So, when were you going to get to the point when it's general, right? Is our intelligence really general either? Anyway, okay, park that. We can come back to that another time. Anyway, by mapping these neural and computational architectures, I highlight how AI models progressively mimic the brain's complexity, basic pattern recognition and association to advanced reasoning. I outline current challenges such as overcoming learning limitations and achieving comparable levels of neuroplasticity. That's the other big thing. So increasing the ability to be more redundant, make changes. This will be a big thread across, because biologists, right? Biological networks, huge inspiration for some of the more advanced other types of models that are coming through now. Okay. But he was also along this same line. In biology, the networks have way more redundancies. They have loads of other fixed paths that are just going off all over the place, right? And that's really important. Yeah. Are addressed alongside emerging innovations like neuromorphic computing, right? So that's the big thing. That was the breakthrough, right? So he's like, we're going to do this. We're going to link. And he provided the framework that pulled all these things together. And that's why we got androids that dream of electric sheep, yeah? Given the rapid pace of AI advances, this work underscores the importance of continually reassessing our understanding as technology evolves exponentially. Yeah. So, yeah, and I don't know if most people know this, but yeah, the foundation of the modern, the very modern now is actually different again. There's another set of authors that have kind of come in, and so we've got I'm not as up to date with this stuff yet, but you've got the advanced fractal topologies, right? They bring in the pure math stuff that's kind of out of my pay grade. So it's like new architectures, non-world, non-human topologies. So, I'll use a little metaphor, right? So if you imagine you've got the, our normal sort of human approach to topologies is kind of just like a flat, non-transformed map. Yeah, so it's just square, just a flat sheet of paper, right? They're using the equivalent of mathematical stretching to turn it into a non-Euclidean geometry, topology. Okay, it's way more complicated than that. Okay, so like a sphere, right? So those two things can't be exactly matched, but you can transform one from the other, and you get all sorts of interesting properties when you generate more topological space within the networks, right? So which leads to more redundancy, which leads to more computational power, blah, 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 blah. It's all very complicated, but the key thing is it's as far beyond the flat piece of paper to a complex 3D shape, right? Except it's in a network space. So that hadn't been integrated yet, but all the biological stuff, he produced the framework for it. And he did it studying people who were insane. Yeah, Bethlem Royal is for criminally insane. Yeah, people. So yeah, are all of our AIs mad? No, couldn't be, right?